In this video, we'll be learning about non-uniform motions. During these types of motions, the change in displacement per unit time is not equal. This is because the object travels with an acceleration. There are three main types of accelerations. They are: the first one is uniform acceleration, the second one is increasing acceleration, and the third one is decreasing acceleration. The first type is uniform acceleration, the second type is increasing acceleration, and the third type is decreasing acceleration. Now under this, let's talk about uniform acceleration. For an example, let's say this car starts from rest and it moves with an acceleration. When time is equal to 1 second, it gains a velocity of 2 meters per second. When the time is 2 seconds, it gains a velocity of 4 meters per second. When the time is 3 seconds, it gains a velocity of 6 meters per second. Now here we can see that the velocity of the car changes from time to time. That is, it increases with uniform intervals during each second. So we can tell that this car moves with a uniform acceleration. To confirm this, we can use the equation A is equal to delta V over T. Now, if we consider the first case, acceleration is equal to change in velocity, that is 2 minus 0 meters per second divided by 1 minus 0 seconds, that is 2 meters per square second. Now, if we consider the second case, acceleration is equal to 4 minus 2 meters per second divided by 2 minus 1 second. Therefore, acceleration is 2 meters per square second. Now, if we consider the third case, acceleration is equal to 6 minus 4 meters per second divided by 3 minus 2 second. Therefore, the acceleration is 2 meters per square second. Now you can see that in the first case the acceleration is 2 meters per square second, and in the second case you can see that the acceleration is 2 meters per square second, and also in the third case you can see that acceleration is again 2 meters per square second. Therefore, the acceleration does not change over time. For these types of motion, we call it uniform acceleration. Increasing acceleration is something like this. Let's see the velocity of the car at each second. When it starts, the velocity is 0. Next, it increases up to 2 meters per second, then up to 5 meters per second, and finally up to 9 meters per second. As you can see, the difference between values is increasing with time. Therefore, let's find the acceleration in each stage. In the first stage, we have 2 minus 0 meters per second divided by 1 minus 0 second. This is 2 meters per square second. Then we have 5 minus 2 meters per second divided by 2 minus 1 second. That is 3 meters per square second. Next we have 9 minus 5 meters per second divided by 3 minus 2 second. Therefore, A is equal to 4 meters per square second. As you can see, the magnitude of the acceleration keeps increasing with time. In these cases, or in these types of motion, we call it the object is traveling with an increasing acceleration. Now we have the final part, which is decreasing acceleration. Now if you take a look at the values, when t is equal to 0 second, the velocity is 0. When time is equal to 1 second, the velocity is 5. Then in the next second we have 8, and after that we have 9. As you can see, the magnitude will increase, but the rate of increment is decreasing. Now if you find the acceleration in each stage, let's say this is the stage 1, this is the second stage, and this is the third stage. The first stage, if you calculate the acceleration, we have 5 meters per square second. Then in the next stage we have 3 meters per square second. In the fourth stage we have 1 meter per square second.